Hi class, how are you? Hope you and your family and loved ones are all doing okay and staying safe. Now we're going to talk about chi-square goodness of fit test today. And we're going to talk about what it is. We'll hop over to RStudio for a demo. And then it'll be your turn to try your hand at running this particular analysis in RStudio. So let's get started. So you're already familiar with this slide. So now you know that we are going to be on the second part of the chi-square tests series, and you will be testing how the distribution of categories for your variable matches a particular population distribution. So this is a goodness of fit test. So for the chi-square goodness of fit test, you need one categorical variable. And you may be wondering, what am I supposed to do with just one variable? Well, what you're doing with it is that you're going to look at the distribution of the categories or levels inside that variable, the observed distribution in other words, and then comparing that against a known population distribution. And so for example, let's say that you surveyed 100 college students and asked what their favorite pet type was. You gave them 4 options: dogs, cats, birds, and reptiles, and you tally the number of people who identified one of those 4. And so everyone falls into one of these 4 categories. And so this is the observed distribution, what you got out of the data. And let's say that your hypothesized distribution, or the expected frequencies, are that equal numbers of people chose each pet type. And so you have an even distribution across these 4 categories. And let's translate that into hypotheses. And so the null hypothesis would say that the students' favorite pet types are distributed the same as these expected frequencies like this. So in this case, it's an even distribution where each category has the same number, or the expected frequency. So you're saying that the observed frequencies are not significantly different from this table. The alternate hypothesis says that students' favorite pet types are distributed significantly differently from this population distribution. So you're saying that what I found in my data is different from this. Now, when you run the goodness of fit test, you think in terms of proportions more than the actual expected frequencies, and you will see that when we transition over to RStudio. And so let me just quickly show you how you would derive the proportions. And so the total n here is 100. And for each of these categories, you want to think about the proportion or the percentage of the expected frequency that goes into that category. So in this case, there are 25 dogs out of 100, and so the expected proportion is 0.25. And of course, you would repeat that because all of these are evenly distributed, have the same expected frequency, and so the same expected proportions. Now, what if the expected distribution was different, and so you thought maybe dogs and cats would be more popular than birds and reptiles, with reptiles being least popular? And let's say that your total head count was still 100, then you would divide the expected frequency for each category by that total head count to get the expected proportions. So you would get these proportions. And so hope you get the idea about what it means to have expected proportions, because we'll plug that into RStudio when we get there. And so you plug those things into RStudio, what is it doing in the background? Well, we're back to our good old friend chi-square. And so mathematically, it's comparing the observed frequencies, the actual frequencies in your data, against the expected frequencies. And when researchers run the goodness of fit test, there are a couple of different ways in which they often think about expected frequencies. Sometimes they think that there'll be equal frequencies, which is often the default for many researchers. So they don't really know which category is going to be more popular than the other. So they just kind of say maybe all the categories evenly distributed in terms of frequency. Or maybe they have a particular expected population frequency, and so they know what proportion of the sample would be expected to fall into each category, and then they would plug that in. And then the degrees of freedom for this analysis would be number of categories minus 1. And so let's switch gears a little bit and think about our Psych 300 Data 1 dataset. And so what if we had these couple of research questions? And so maybe the first question is, are there equal numbers of participants working in research labs versus not working in research labs? And so that was kind of like that expected frequencies would be an even distribution kind of a situation. Or perhaps you think that that's a bit of a high estimate. And you have a second research question that's separate, where you ask whether 10% of the participants work in research labs. And so does the data reflect this type of distribution? And so when we translate these into the intuition behind the chi-square goodness of fit test, so here is the intuition behind research question 1. And so there's your observed proportions. And so this comes from the data. So I put question marks there because this is an empirical thing. We would need to look at the data to see the observed proportion. And so compares this observed distribution against the expected population distribution. For research question 1, then we expect things to be 50-50, right? And so 50% no, 50% yes, and that is the expected proportion. And so you would compare the observed proportions against the expected proportions. For research question 2, once again, the observed distribution comes from our data, and that's compared against the distribution where 90% of the participants said no and 10% of the participants said yes, and those were the expected proportions, and this would be the expected proportion distribution overall for research question 2, and so those two distributions are being compared. And so in both instances, when you translate those into hypotheses, then the null hypothesis would say that the observed distribution is not different from the expected distribution. Whereas the alternate hypothesis would say the observed distribution in your data is significantly different from the expected distribution. And so that is the idea behind the chi-square goodness of fit test. And so let's talk about how that is run in RStudio. And so we're going to take a look at one way to run the chi-square goodness of fit test in RStudio, which is to have your data in a frequencies table. And so I'll show you how to do that. And we're back at using our good old friend chi-scoot.test function. And you would write down the name of the table, and I'll show you what I mean when we get to RStudio, comma, and then p equals, and then plug in the expected proportions. And this expected proportions part will be actually a list or a vector of proportions that you create in RStudio. And so I will meet you in RStudio to show you exactly what I mean by this. See you there. All right, so welcome to RStudio. Now I've begun to set up my working environment. I first of all set my working directory. And just as a reference, you can actually see your working directory over here in this little bar. And so if you're ever curious about what your working directory is set to, then you can look at this bar right next to the R version in the console window. And that tells you what working directory you're working in. Now I've imported my dataset, and do note that my dataset is a different one than what you have. And so, one thing that might be good for you to do is to just follow along in your own RStudio and try running code on your own dataset. But do note that my numbers may not match up with yours because my dataset is different. Let me attach my dataset so that it's easier to work in this environment. And so I've just attached my dataset, and I've written down some comments and notes here. Now we want to start setting up our chi-square goodness of fit test. Pretty exciting stuff. And so first of all, you need to know how to enter your dependent variable. In this case, there's only one variable, research, which is our variable, as a table in our code. And so a thing that is good to do is to just check out the frequencies data for your variable. And so let me do that. But I'm going to do this by running the table function so that we can kind of think about what to tell RStudio to work with. And so let's do table and then run it. And so now we see a table of observed frequencies for each category for the variable research. And so 111 people said no, and then 3 people said yes. And so a bit different from the expectations for some of our research questions, isn't it? Now, something to note is that this table is not yet an object or entity that RStudio can work with as part of analysis. It's basically just output. And so we want to allow RStudio to save this table as an object that it can work with for data analysis. And so you can do that by first of all naming that destination object. So I might say table research, not exactly the most imaginative name, but simple enough for me to remember what it might be about. And so I'm gonna say save an object called table research that contains this particular table I just saw. And so now you can see that table research has been saved. And if you're curious about seeing what table research looks like, then you can certainly just print it. So you might remember they can just print it by typing in the object name. And so ta-da! And so you see it has saved the same table within table research. But now we can tell RStudio to work with it. You will see what I mean in just a second. Now keep in mind that RStudio will organize categories in alphabetical order. And so when it's thinking about organizing this information, it's thinking about the category no first and then yes later. And this will begin to matter when you start typing in expected proportions into R. And so let's now start thinking about asking for that chi-square goodness of fit test. Here we are. And so you might remember that we have the chi-square.test function. And in this instance, we're going to actually ask RStudio not to work with the variable research because it's just going to get surprised and ask, what is this? It will get confused. But we've saved that table, and so we can just give our table research. And then you want to tell RStudio the expected proportions. And you might remember the concatenate function. You will want to save your expected proportion as a list or a vector, you might remember. And so you want to tell what proportion of the sample you expect to go into the category no and then category yes. And so remember that RStudio will alphabetize the categories. And so in this instance, no and then yes categories in that order. And so the expected proportion for research question 1, you might remember, was basically 50%. And so 50 and then 50% for the category yes. So what I'm trying to tell R is that please run a chi-square goodness of fit test on table research, so this table, with the expected proportion that is 50 and 50. 50% no, 50% yes. And so I've run it, and there you have it. My goodness, what an incredibly small p-value. So we know that our expected proportion of 50-50 is very different from the actual data that we have. Now, you probably could have told me that by eyeballing the data. I know. So what about research question 2? And so in this instance, we were thinking that only 10% of the students would say yes. And so let's see if the distribution is significantly different from that. I just copied and pasted this over, but now we have to update the proportions part. Now, can you tell me what number to put in first? So you may have been tempted to do something different, like 0.1 first, because you're thinking 10% yes, 90% no. But you might remember that R is thinking no is the first category, and so you'll be 90% no, and then 10% yes. And so that is our expected proportion for research question 2. And so let's try running that. Interesting. And so we get this result, and this time the chi-square value is much smaller, p-value also more temperate, no longer using scientific notation. Pretty cool. Now all of this is well and good. We've run our tests. That's exciting. But of course, there's more to do, which is to actually interpret what we found. And so let's go over to PowerPoint and continue talking about this. So here was the result of our chi-square goodness of fit test for research question 1, where we expected the same number of people to say yes versus no in that question about whether you were currently working in a research lab. And so in order to interpret this test, you can take a look at the p-value. Is a p-value less than R alpha or 0.05? Yes, the p-value is very, very small, and it's less than 0.05. And so would you reject or retain the null hypothesis? You will reject the null hypothesis. We have a significant result for this chi-square test. And so we know that our observed frequencies, our observed distribution was significantly different from this expected proportion. And so if you write this up in APA style, you would say something along the lines of, this test revealed that participants were not evenly distributed in terms of whether or not they were working in a research lab. And then the same format as before about how you write up your chi-square result. What about question 2? And so we got this result. And so it's a p-value less than our alpha of 0.05. Yes, it is less than 0.05. Do we reject or retain the null hypothesis? We again reject the null hypothesis, so our distribution is significantly different from the expected distribution. And so translating that to APA style, here's one way to write it up, which is to say that the sample had a significantly smaller proportion of students currently working in a research lab. So this number is basically the number of people who said yes divided by the whole sample size. And so that turned out to be 2.6. I just calculated that. Then the expected proportion, which was 10%. And then the chi-square result again. And so there you have it. All right, so now it is your turn to run your own chi-square goodness of fit test. And so following the procedures that you've seen in this lecture, please go ahead and test the following research questions using your dataset. First of all, do an equal number of participants plan to become a therapist versus not? And so this is basically that 50-50 type of a situation. So did 50% say no and 50% say yes to that question about becoming a therapist, which is the variable therapist? The second question is, do 80% of the participants plan to become a therapist? So basically the expected proportion would be that 80% said yes to that question about becoming a therapist. Once again, the same variable therapist. And so go ahead and try running this in RStudio and let me know what you found out. You can borrow my code if that would be helpful, but make sure that you're updating information about your data set and the variable you're using and the proportions that you're expecting so that you can answer these research questions. And as always, if you have any questions, feel free to get in touch. Okay, so that's all. Great job so far this week. Hope you have an amazing time working with your RStudio, and I will talk to you soon. Take care. Bye for now.